I'm very honored to be the kickoff speaker here at the very first performance.now. Thanks everyone for coming. It's going to be a great 2 days. I actually haven't done a talk in quite a while, I think almost a year. And, so I was a little nervous about this. And I also had this quandary where, I'm part of the folks that invited all the other speakers here. And I wanted to deliver a stellar kickoff presentation. But I thought, if I do that, the bar is going to be really high for all the subsequent speakers. So, as the host, one of the hosts, I thought it'd be a lot better to deliver, kind of a really bad talk. Set the bar low so that you can all look forward to better and better talks as the 2 days go on. So let's see how well I do at achieving that goal. So I'm going to talk about making JavaScript faster. And you can tell from this slide, the summary is JavaScript is the biggest problem for web performance today. But we're going to try to take something that is a big problem and see if we can reduce that. And I know we can. I'm going to start with this quote from, I have to turn this on. From Knuth, probably one of the most famous computer scientists today. Thank you. And he's very well known for this quote. This is used a lot. We should forget about small efficiencies, say about 90% of the time. Premature optimization is the root of all evil. Most of the time when people reference this citation, they stop there. But it's this next part which is the important part. Yet we should not pass up our opportunities in that critical 3%. And this can be applied to a lot of different disciplines, certainly to web performance. And so the trick as someone who wants to make sites faster is to find that 3% and figure out what to do to optimize it. So what I want to do today is I want to look for some long poles in the tent. Now, if you're measuring literally a long pole in the tent, that's pretty easy to figure out how to do. You know how to measure it. You're going to get out a tape measure. You know the units you're going to use, meters, yards, whatever. When we're doing web performance, it's a little trickier to figure out what to measure and what units that should be. So here's a quick slide. I'm not going to go through all of these. I think Paul is going to go through these one by one tomorrow. But we certainly have a lot of metrics, performance metrics to choose from, and every year it's growing, right? What I'm going to do today is I'm going to look for some long poles in the tent, and I'm going to primarily use data from the HTTP archive to substantiate these claims that these are long poles in the tent. I don't know how many people know about the HTTP archive. This is a project I started back in 2010. Pat Meenan, Ilya Grigorik, and Rick Viscami took over the project about a year or two ago, and made me feel a little embarrassed about how little I did with it the first 6 years, because now it's really taking off. There are up to 1.3 million URLs that they look at twice a month. All the data is available in BigQuery, so it's very easy to query. And I'll post this slide deck after I get off stage, and all the queries that are used for the charts are in there. So I just wanted to start off with these metrics that we just went through to look at the medians across all 1.3 million sites, to look at what that looks like in a timeline, to get an idea of the sequence of them and how painful these performance metrics are for people using these websites. Now, I don't say explicitly, if I don't say mobile, if it's just blank like this, these are all desktop measurements, but for most of the charts, I've also gotten the data for mobile. And so we can look at both of these, and what I want to do today is not focus on any of these metrics. We have a bunch of these. For me, the most important thing when I'm working with people to improve performance is to focus on getting content to users quickly. And so we have a handful of rendering metrics here. These, I generally recommend one of these for people to focus on. I don't want to talk about those though. I want to talk about these gaps. These are where JavaScript is inflicting its pain on the user experience, right? JavaScript is blocking that initial rendering from happening and the rendering of other content in the page, and then is pushing out these interactivity metrics because the page is not deemed interactive until the JavaScript has stopped inflicting its pain. And so what can we do to try to mitigate the pain inflicted in these gaps? To explore that, I want to go back in time a decade or so and look at how JavaScript has evolved in the browser. Now, personally, I think I'm a good person to do that. Some people have called me the godfather of web performance. Some people who aren't quite as nice have called me the grandfather of web performance. And so if someone's going to go back in time and look, it could be me. And I think, I don't want to say there's ageism going on here or anything, but this has come up a lot. And I kind of want to flip that around. Like, yeah, I have been doing this for a while, and I think that's a good thing. I mean, compare that to what the speakers we have this week were doing when I started web performance back in 2003. Most of them look like this. Now, I procrastinated a lot putting this deck together, but I got the idea for this slide. Oh, I didn't finish. Wait for it. Who's the last one? Jason Grigsby. Like me, Jason's a little older than the rest of the speakers. I'm much older. So I procrastinated, and then I got the idea for this slide, and it got me kind of excited. So of all the slides that I have to get done to deliver this talk on making JavaScript faster, this was the slide I started with. And it took me like 2 days. Like, I had to do all this research to find, these are the actual baby photos of the speakers. No, that's not true. But we do have one of Paul. Paul gave me one yesterday. He sent me one, so we do have one real one. So this is not actual factual data, unlike the other charts I'm showing. That's not made up stuff. This is a little bit. So let's get going. Let's look at IE7. We're going to go back to 2007. IE7 actually came out in 2006, but 2007, everyone's using IE7, right? Chrome's not out yet. And this is what JavaScript looked like, okay? So this is Turner.com. They've got about 14 scripts on their page. And what do we notice? They're loaded daisy chain fashion, only one at a time. One at a time, the browser's HTML parser hits a script tag, downloads the JavaScript file, and while it's doing, and it parses and executes it, and while it's doing that, everything else stops. And so you can look at this. This is taking forever, right, to download this JavaScript. The HTML parser is blocked, the main thread is blocked, the network activity is blocked, and this behavior is what I noticed and resulted in the creation of that rule, put JavaScripts at the bottom. Because these scripts, they're blocking the HTML parser, but only for those DOM elements that follow the script tag. So if you have the script tag at the bottom, all the DOM elements above it, which is basically the entire page, are able to render. So that was the motivation for that rule. Then what happened in 2008 was IE8 came out with something called the Preloader, the look-ahead parser, the speculative parser. And this is the most important improvement browsers have ever made to improve web performance. What it does is, in addition to the HTML parser, we have a lightweight look-ahead parser, Preloader, that scans for tags that could initiate network requests, like script, link, image, and queues all of those requests up, actually applies some intelligent prioritization, which is constantly changing as we learn, as the browser teams learn more and more about the web, and kick off those downloads sooner. So that Turner.com page now looks like this, right? So what do we have here? This is actually a waterfall chart from speedcurve.com. I'll do a little digression. We got the film strip up here. We've got the browser CPU timeline down here. We've got the waterfall of all the requests. And we do this neat thing that I think other waterfall charts will start picking up soon, is we distinguish scripts that are loaded in blocking fashion from scripts that are loaded asynchronously. And so we can see Turner.com still has about 14, I think out now it's actually 15, blocking JavaScript files. But whereas before, these 14 files took 6 seconds to download, now we're doing them in parallel. Before we did them one at a time, now we're doing them 6 at a time in parallel, right? So we're getting these scripts that used to take 6 seconds down in about 1 second, 1.5 seconds. And so that's going to make everything a lot faster. And people have studied this, and Tony Gentlecore, I think, has some high-level stats from Chrome on this topic. And so this was a really important development. So I want to look really quick at how this rolled out in IE7, IE8, and other browsers. And we're going to do that by looking at Browser Scope, which is another project I did. Tim, thank you very much for mentioning that. It doesn't get as much attention these days, but it has this historical data. It's been running for, I don't know what, 5 years or so. And it has this historical data about features in the world of security and rich text controls and other areas, but I built a test of suites for performance. And one of the things I tested was downloading scripts in parallel. And we can see that this changed between IE7 and IE8. And I like to think that I had something to do with that. When I was still at Yahoo back in 2007, the IE team invited me to come up and talk to them about what I thought browsers could do to make the internet faster. And this was the _1 thing I suggested, and it was funny because half the team said, oh yeah, we already do that, and the other half said, no, we don't. And sure enough, in IE8, we saw it come out. And so, you know, sometimes IE doesn't get the love, especially back then, that it deserves, but IE8 was actually the first browser to have the preloader, followed by Chrome and Firefox the same year, later Safari, and then much later Opera. So the preloader, awesome, really pulled in this script loading, made JavaScript much less painful on pages, right? But it still didn't solve everything. What are some of the problems that we see here? So while we've got these blocking scripts, rendering is still blocked until all the scripts are done being downloaded, parsed, and executed. The order of execution of the scripts has to be preserved. So even though, for example, this script finished downloading much earlier, it had to wait until this point before it could be executed. That's what these green and red lines are. They're showing the execution time for each script. And so because these have to be executed in the right order, it pushes that finished execution time further out than it could be if they were loaded async. We also notice that while these scripts are being downloaded, the browser's just twiddling its thumbs. Thumbs? Do they have 2 thumbs? I don't know. And we don't want that. We want everything to be pegged. You know, for performance, a key thing to always think about for improving is parallelization. And here we don't see that. We see the browser not doing anything until finally all the payloads arrive, and then it kicks in and it pegs the CPU and it blocks the main thread so the user can't interact and we get janky pages. Whereas we have these async scripts and we can see that they're being downloaded and executed much more quickly. So the async attribute came out in 2009. It was first supported by Firefox, and then Chrome, Safari, IE10, so IE was a little behind on this one, and Opera. Now, during this time was when I did a lot of work on, and my second book, Even Faster Websites, focused on what really are hacks to try to get scripts to load asynchronously even before all the browsers supported the async attribute. The async attribute, just being able to add that word to your markup, does a lot of benefit. But during this period, before we had wide adoption, we had to use those other patterns of dynamically loading scripts and things like that to get async behavior to happen. But now that we have the async attribute, we can get pages like this, where this is New York Times. All the scripts are loaded asynchronously, and we can get the initial rendering to happen very quickly. I didn't look at this too much further. It looks like they've got some initial rendering of content, and then it disappears. So if there's anyone here who knows anything about web fonts, I don't know. Oh, hey, Zach, how are you doing? It might be worth investigating that. But at least their initial render is highly accelerated because of the use of async. So I wanted to, again, dive back down into the HTTP archive data and look at the adoption of async. This actually, I call it async, but also if you use the defer attribute, you're lumped in here as well. And so we can see, we didn't start tracking this in the HTTP archive until 2015, 2016, but we can see that there was a jump in the number of async scripts in May of 2016, and those were probably synchronous scripts that got converted to async. And I would actually guess that these are from popular third-party widgets like Facebook, Google Analytics, things like that. And so we saw that drop, and really for blocking scripts, for synchronous scripts, it stayed flat. It's been flat since 2016. We're looking at median here. And we have had an increase in the number of scripts in the typical page. But those, luckily, have all been async scripts that have been added. So we're seeing good adoption of async, right? That's good. But what do we see from this? A majority of scripts on pages today are still loaded synchronously. So we're not getting that benefit of letting rendering happen sooner, of taking advantage of the CPU and exercising it throughout the page load, because we still have a lot of blocking scripts. Another side thing we could look at here, if someone wanted to investigate, is why the number of scripts always jumps in May. I don't know. I mean, that's 3 years in a row. That's, I think, more than a coincidence. My guess is there's something going on there, but I don't know what. But it wouldn't be that hard to track down. So I'm going to have this slide running throughout the talk, gathering these suggestions about long poles in the tent and what we can do to fix them. So, this one's pretty obvious, like load scripts asynchronously. Even better, use the defer attribute, because if a script can be loaded asynchronously, basically what you're saying is this isn't critical for the HTML parser. We can render the page, at least partial parts of the page, skeleton maybe, without this script. Well, if we can do that, let's get the HTML parsed as quickly as possible. And what defer says, it's similar to async, but it says, normally with an async script, once it arrives, it's executed immediately. And so if it's very fast, if it's in the cache perhaps, it could actually block the HTML parser, which we don't want to do. Defer says, don't actually execute the script until the HTML is parsed. So as long as you're saying that the page doesn't need this JavaScript in order to start rendering, let's delay that a little bit further just to get the HTML parsed as quickly as possible. So we have New York Times again. We have this beautiful parallel loading with the CPU is being used without pegging for long times. But we still have to wait for these scripts to come down before they can be parsed and executed, right? And so, we're getting this JavaScript that's executing kind of late in the page, and 0.7 seconds for a start render is pretty good, but we'd like it to be even faster. So what can we do to get these scripts downloaded even earlier than they are now? We can use the Linkrel Preload header, and Yoav, who's speaking this week, had a lot to do with this. Basically what this says, you put this link tag hopefully in the head of your HTML document, and it tells the browser, I'm going to need this resource later. You should start downloading it now. Even with the look-ahead parser, this will get the download kicked off early. And it's really important to use the as attribute because, like I said, with the download order, there's a lot of logic browsers have built about prioritization. And if you don't specify that this is a script and should be a high priority, it could be given a low priority, or in fact, it is given a low priority. Even better than doing this in markup is using a link response header, because this will be seen and parsed by the browser before any of the HTML is parsed, right? And it could even optimize intermediaries, like your CDN could see this, could sniff this in your HTML document and make sure that it has it in the CDN cache from origin before the browser even requests it. So good to use the headers. You could even do both. Now there's this interesting chart from Chrome that looks at the adoption of Linkrel Preload. And it's got pretty rosy stats here, 26%. That sounds pretty good. The thing is, this is the use of Linkrel Preload anywhere in a page, right? And that's not really what we care about. What we're trying to do is we're trying to get these, especially these rendering metrics for the page, to happen sooner than they are now. And so if someone like Twitter or Facebook have an iframe or something and they're using a Linkrel Preload, that's good. I don't want to discourage them from doing that. But as far as the user is concerned, as far as you're concerned about your website, that's not getting your content rendered and downloaded any faster. So what I did was I restricted it to look at, in the HTTP archive, to just look at the HTML documents for the main page that were using Linkrel Preload for scripts, because that's the most painful. And that 26% drops to 1%. So this technique, which can really help with getting scripts down sooner, is not being widely used across the web. So if we go to our list of techniques that we should be thinking about when we go home on Saturday or Friday night, preloading scripts is something that you should consider if you're not doing that, and 99% of you in the room are probably not. Well, that's not true, because you're all performance people, so it's probably, I don't know, maybe 80%. But across the web, it's 99. Okay, so again, we're back at New York Times. We could get these scripts to download sooner and get some of that pain out of the way a little bit sooner if we use Linkrel Preload. But I briefly mentioned this red and green stuff in there, and this is CPU. And what the red indicates is it's considered a long task. A long task is any time that JavaScript blocks takes over the main thread for more than 50 milliseconds. And that's going to create this janky experience where the user is trying to interact with the page or wait for something to render and it's delayed. So we really want to focus on reducing the impact JavaScript has on CPU. Well, that's a hypothesis. We don't know yet how much impact JavaScript has on the browser, the main thread CPU. So what did I do? I got some data from the HTTP archive about that. It has CPU information in there. And we see that JavaScript is responsible for more than half of the CPU consumption across all pages, all 1.3 million pages being tracked in the HTTP archive. And specifically, it's evaluate script and function call that are taking the most time. Parse compile is talked about a lot, and it is, a bigger slice. It's the third biggest slice, but evaluate script and function call are bigger. And actually, you could blame JavaScript a little bit more for some of the layout that's going on, because there's still a lot of JavaScript that creates forced reflows. Just to let you know, I did the color coding here. Orange is JavaScript, purple is layout, green is paint, blue is loading. So this is a median from the HTTP archive for desktop. We can look at 95th percentile. Oh, and the total is 433 milliseconds. We can look at 95th percentile. It jumps to 3.6 seconds. And the 99th percentile, 8 seconds, right? So this doesn't mean the HTTP archive is based on synthetic data. We're not looking at real users. And we're not looking at a frequency distribution for a single site. What we're saying is 5% of sites out there, if you go to them, have over 3 seconds of CPU time taken by JavaScript. And 1%, which might not be a lot, but every 100 websites you go to is going to have 8 seconds of JavaScript CPU time. Now, of course, things get worse if we look at mobile. The median is 1.1 seconds. The 95th percentile is 9.8 seconds, and 99th percentile is 19 seconds of JavaScript CPU time, right? Now, I'll be honest, mostly I did these pie charts with these colors because I just think they're really pretty. And that's true of this next graphic as well. I wanted to show the relation of those different charts to each other and how that's growing. And so we have the median desktop is the smallest. We have the mobile 99th percentile is the largest. And we have all the ones in between. it looks a little bit like a snail shell to me. I like that progression. But more than being a beautiful visualization, it's showing something here. As pages get slower, the amount of JavaScript CPU time grows. JavaScript is the main culprit for making sites slower. You could focus on layout, you could focus on paint, you could focus on load, and it's not going to be as important as focusing on JavaScript. So I've substantiated my hypothesis at this point. We need to focus on how much CPU time JavaScript is taking, especially in the areas of script evaluation and function call. Now, one way we can do that is by reducing the amount of JavaScript on our pages. So I've talked a little bit about the number of requests. In this case, I'm showing a time series chart, and I've broken it out by first party blue and third party kind of orangey, reddish brown, brick red. And we see that, back in 2010 when we started, we had 4 first-party scripts, 5 third-party scripts, and now that's flip-flopped. We have 6 first-party scripts and 12 third-party scripts today. And we can also look at size. Back in those old days, we had 53K of first-party, 32K of third-party, and today, third-party has jumped to 258, first-party is 106K. So let's compare these side by side and look at some trends that are kind of scary. The number of requests for first party have doubled, but the number of requests for third party has tripled. The size, the amount of first party JavaScript has grown. Oh, I'm sorry, the requests are up 50%, and the requests for third party are up 3 times. The size for first party has doubled. The size for third party has increased 800%. Back in 2010, the amount of first-party JavaScript and third-party JavaScript was about the same, and now third-party is 3 times as much, 2.5, 3 times as much. So we really need to focus on third-party JavaScript website owners to contain the amount of pain that JavaScript is inflicting on our pages. So going to our list, if you don't already set up performance budgets for us, you should set them up for all the things that you're tracking, especially your most important rendering metric, but definitely for third parties. And even more than that, once you're tracking third party impact on your pages, you're going to need to try to cut it back. We've seen this increase. Now, part of it could be explained by back in 2010, there were fewer JavaScript libraries available. First parties had to do more of the work themselves. And certainly I think what we are seeing here is a shift to where websites are becoming more reliant on third-party JavaScript. And so it makes some sense that some of that JavaScript has shifted over to third party. But it's not just stayed the same and shifted. We've had this shift and it's grown to be 3 times as much. So we've got to track that third-party growth, make sure that we can try to stall that, and then start going on a diet with third-party JavaScript and try to pull that back in. Okay, what else can we do to get that JavaScript downloaded sooner? We can look at Gzip, right? It's quite mundane. Everyone should be doing compression. And I'll admit, before I ran this query, I was really hopeful that I would find some third party that wasn't compressing their JavaScript for their snippet. But if we look at third parties, we can see that they're doing a pretty good job. Okay, now this is kind of a complicated chart. Let me explain it. Let's look at this spike right here at 100. The x-axis is the size of the JavaScript file. And so, for example, this column right here, 100, is all the scripts between 91 and 100K in size, right? And this is showing how much of that third-party scripts in that size range were not gzipped and how much could have been saved if they had been gzipped. So on average, we could have saved, maybe about 10K out of this 100K file if we had gzip turned on across all of the times that script was loaded. And so I was kind of disappointed, like I didn't get, a culprit to point to in the world of third party. And then I did it for first party. And I was dumbfounded. So this is showing, let's look at that 100 spike again. So for first party scripts that are between 90 and 100K, there's an average savings across all those scripts of 50K, right? So if you do the math, it's really about a third of the first party scripts in that size are not being loaded with Gzip compression for first parties. How's that possible? What's going on there? So I did a little look at what these okay, I'm not going to ask for hands, but before I switch, why do we have this spike at 100 for both first and third party? Think to yourself. Don't shout out your answers. Okay, now let's look at it. Whoops. jQuery. jQuery's around 92K. Everyone's using it, and they're not compressing it, right? So all these first parties they've got their own version of JavaScript, and they're not compressing it, and that's why we see this spike at 100K. So again, mundane, but you know what else? It's easy to look at your compression settings and make sure that you're compressing your first-party content. And then the last thing I'm going to talk about is something that I don't have stats for. So I'm just going to point out how you can look at it and suggest that there are a lot of savings to be had here. And that's code coverage, right? So I don't know if people know it. This is built into Chrome DevTools today. You can go into the right menu, click More Tools, click Coverage. You can turn it on, reload the page, and look at each of the scripts, and it will tell you how much code is not being used in each of the scripts. And so, for example, we can look here at this Turner.com script, foundation.min.js. We can look at a prettified version of that, and we can see that there are functions that are in this script but were never called. Now, it doesn't necessarily mean that you can rip those out, because there might be some other page on your site that's using that script and does need it, but it can give you suggestions, and typically there's someone on your team who knows the JavaScript well enough on the site to go, oh yeah, that stuff we ripped out like a year and a half ago. Yeah, we should remove all of that from our JavaScript. So go through, look at the code coverage reports. We're going to get better at this. You can get code coverage in Lighthouse, I believe. We don't have it built into web page test right now, but I'm sure that will be coming soon, and more vendors, performance monitoring vendors, will be reporting that. So I wanted to add that to the list as well. So these are the takeaways from today. Load scripts async. If you can, do defer. That's even better. Preload scripts. It's a pretty easy thing to do, and you'll get that accelerated download. Focus on CPU time, especially around evaluation and function call. Budget third party, set up those performance budgets. Hopefully you have a tool to do that. Double check your compression settings. It's an easy thing to do. And look at your code coverage and try to rip out that old code that's not being used anymore. And that's it for me today. I hope I achieved my goal. Thank you very much.
Thank you, Steve. You want to?
Hey,
we'll
here we go.
Here.
All right. Whoa, feels like a hot seat.
Oh, it's about to be. No, we've got some. No, it's really appreciate it. It's good. There was a lot of good questions that kind of came in as part of this. It turns out people are kind of interested in the whole JavaScript performance thing. You had that long list there. Working on execution and compression and trying to get it to download faster. In your experience, what tends to rise to the top? Like if somebody out there right now is like, I suffer from almost all of these issues, like where do they start?
Something that's really important in looking at these long poles in the tent and translating that into a to-do list is it's not always the case that the long pole in the tent is something that you can have a big impact on. So you need to balance the long poles in the tent, the culprits, with the possible impact you can have to mitigate that pain. And so that's going to depend on your site. Like, did you write all the code yourself? Did you use a contractor? Is most of the pain in third parties? And so you're going to have to like rewrite a third-party library yourself. So it's hard to give an answer on the prioritization of that to-do list. Certainly the biggest culprit that we need to address right now is CPU. That is just taking so much time, and it's blocking what we care about the most, is delivering, not just delivering, getting that rendering to happen quickly, but also not to block the user's interaction with the page and have that janky scrolling and things like that. So CPU is the most important thing, is going to be the longest pole in the tent for most people, but how to actually tackle that, whereas there's something like preload or compression is not going to have as big of an improvement as if you could cut your CPU time in half, but they're drop dead easy. And so really, even though they're not as long of a pole in the tent, and the savings you're going to get won't be as big, they're so easy to do that I would start with something like that. When you're starting to work on performance, it's really, really good for team morale and for how the company views a focus on performance to start with a win, even if it's not huge. Make a change. If it's an easy change and you can show the needle's moving in the right direction, that's a big win.
And sort of piggybacking off of that, you mentioned like preload, Gzip, those are like easy things. The preload 1% thing was a little surprising. I mean, partly because I guess I've never dug past the 26%, but also it just feels like we've done a lot of talking about preload for a while. What do you think? Do you think there's something potentially holding back, or is there something that we can do sort of as a community to kind of bump that forward a little bit more?
Yeah.
Or is it just a matter of it takes a while for this stuff to get adopted?
In my experience, when I look at techniques for improving performance, I break those into different quadrants, but one of them is it something that's built into the browser, like streaming JavaScript parsing is a big win. And everyone gets that. The look-ahead parser, everyone gets that. No one has to adopt it. But then there are other things like Linkrel Preload, adding user timing marks and measures, where people have to actually change their code to get that technique to work. Usually, if something falls into that camp, you're lucky if you can get 5% of the web to adopt it. So 1% is lower than it should be, but we're probably never going to get much above 5 or 10% there. But we should evangelize that more. I think certainly if there are people here who are performance monitoring service providers or performance consultants, they can evangelize that more. We can, like, I don't think at SpeedCurve, I don't think we highlight the lack of the use of preload. I don't think we surface that anywhere. I don't know if Lighthouse does. So we could start evangelizing that more in our tooling.
Makes sense. And then there was several questions that came in around this combination of preloading assets that are async or deferred. Is there a potential gotcha into sort of pairing those together? Like, if async is about pushing off the execution of the script until later, does there come to be a problem if we load it too early in this page?
Yeah, not if it's deferred, right? And so I tried to kind of push that prefer, defer. I got a blog post out about that. I would mostly recommend, so if you're loading a script async or defer, like I said, you're kind of telling the browser, this is JavaScript I need, but it's really not that critical. I don't care if you kind of load it a little later. But if it's in the cache and you say async, especially if you preload it, then before the HTML is fully parsed, it could block the parser by being executed as soon as the JavaScript comes down. And so using defer would be better. But the problem that can happen is when you say Linkrel Preload, you can say as script, but you're not able to tell the browser that this is an async or defer script. So it all comes into those prioritizations. Async and deferred scripts in markup have a lower priority than synchronous scripts, which is good because synchronous scripts are inflicting the real pain of blocking rendering. But if you say preload an async script, it actually gets promoted to the same priority or higher priority. There's a debate going on about which of those is true. But it will get a higher prioritization as far as downloading. So you might actually preempt a synchronous script that's more important to get downloaded by a Linkrel Preload async script. So I would generally say don't use Linkrel Preload for a script that's async or defer. Unless you have use it for synchronous scripts. If you don't have asynchronous scripts, then yeah, sure, go ahead and use it for async. Although I would probably do style sheets before I did async scripts preloaded.
Okay. All right, well, thank you. There's more questions, but we'll have to catch you, I think, probably during the break. Well, you're going to be kind of around, I assume, right? People can pull you aside.
No, I'm bailing.
You're bailing.
Yeah.
You're out of here. This is it. All right. Thank you, sir. Thank you, Steve.
Thank you very much.